Hey guys, it's Jose. I was getting a little stir crazy and decided to go outside and spend some time walking with Toby. Right now we're walking to the park. I'm walking to Cheeseman right now, and you'll notice that I'm walking in the middle of the street. Some of the streets here have been closed down to allow people to social distance and walk a little bit farther apart. So that's why I'm walking in the middle of the street. I'm not breaking the law. Anyways, I thought I'd start today's video with some mental math. But for mental math today, I have a riddle. So, your riddle for today is a word I know, 6 letters it contains. Take one away and 12 remains. What word is it? I'll repeat that one more time. A word I know, 6 letters it contains. Take one away and 12 remains. Couple of clues. This is a unit of measure, and the number should give you a big hint. Okay? Give me your best answers and leave it in the comments below. All right? Great job. Hi, so Toby and I are at Cheeseman Park here in Denver. Yeah, it's gorgeous. Not a lot of people out here, which is good. So for today, you are gonna grab your supplies. And what you are going to need for today's lesson is a pencil and your notebook. Today you're gonna need your home connections book and your student books. So let's go ahead and grab those. While you guys are grabbing that stuff, Toby and I are gonna walk home. All right? See you guys later. All right, everybody, let's go ahead and get started. Let's go ahead and open up our notebooks to a brand new page, okay? And at the top, like I said earlier, we're going to talk about liquid volume today. So let's go ahead and find a new page and open up our notebooks. So find a new page, and at the top, let's go ahead and write liquid volume. Here is your title. All right, so liquid volume. So for today's lesson, we're continuing this idea about the series race, the distance challenge flyer. For today, we're not really going to reference it as much as we have in the past, but we want to keep within that same idea of thinking about organizing a race like the one on that flyer, okay? Today I'm going to put you in that seat of being one of the organizers. So a lot of these questions I will be directing to you. And I want you to really take that in. I really want you to apply that to yourself. How am I going to problem solve as an organizer of this race, one of the many organizers of this race? And how am I going to problem solve and make sure that the racers have enough, today we're talking about liquid, so enough water for their race, okay? So here's our scenario. You are organizing the race, and you want to set out water stations for runners. This is gonna be your job for the race, okay? Before we even delve into numbers and doing ratio tables or number lines or whatever it is, I want you to first think about how much water do you think a racer is going to need, and how would you measure that? So would you measure that in like inches or minutes, maybe kilometers? How would you measure liquids? How would you measure a water that runners need? Go ahead and shut it out. About how many? Okay. Cool. So yeah, there's plenty of different ways to measure liquids specifically. In the past in our class, we have talked about milliliters in liters. People have talked about ounces, as in liquid ounces. In your refrigerators, if you have containers of liquids, such as milk or juice, you know that they have gallons, half gallons, pints, quarts, liters of soda, for example. So there's many ways to measure liquids. For today, we're going to go back and revisit milliliters and liters, okay? So thinking about how much water a racer might need, some of you might have said maybe a cup of water, maybe a gallon of water, and it's said that the average racer at a water station needs about 250 milliliters, okay? So let's keep that in mind, 250 milliliters. If an average racer needs 250 milliliters, how many milliliters of water will the first 4 racers need at a water station? Okay? I want you to think about that first. What are some of the strategies that we can use for that? Okay? I want you to pause the video and brainstorm a little bit, and then we'll come back to it. Okay? All right, great. Cool. So the strategy that I thought about is a ratio table. And that's the one that I want us to use for today's exercises, okay? So with a ratio table, I can figure out how many milliliters are going to be needed for my first 4 racers at a water station. I should say your first 4 racers in a water station, okay? So let's try to figure this out. I have created my ratio table so that on one side I have the number of racers, and on the other side I have the number of milliliters. So in your notebooks, I want you to copy this down. And I said that we're going to figure out how many of the first 4 racers, how much water they are going to need at that first station. So we're going to do 1, racer 2, racer 3, racer 4. Go ahead and pause the video here so that you can fill in your ratio table here. If one racer is going to need 250 milliliters, how many milliliters of water will 2 racers need? 3, and then 4. Pause the video, come back and figure out how much water the first 4 racers are going to need. All right, so what did you get? Let's see, let's compare what you have in your notebook with what I have on my ratio table. So I said that for my first one, they need 250. For the second one, they would need 500, followed by 750, and then 1,000 milliliters, okay? One strategy that we could have used is we could have used our knowledge of money, for example. We know that quarters are 25 cents. We know that 2 quarters is 50 cents. 3 quarters is 75 cents. And then $1 there. Okay, so when adding by 25s, good strategy to use is knowledge of coins and quarters and dollars to make that a little bit simpler for you guys. Okay? All right. So up here, we got to 1,000 milliliters for our first 4 racers. Now, did 1,000 milliliters, did that ring any bells to anybody? Let me ask you this. What is a conversion, or what is an equivalent value of milliliters and liters? Who remembers that? Okay. Hopefully some of you are raising your hands and some of you are shouting out the answers. That's okay. That's great. I love this. All right. So yes, some of you clicked and you're like, oh, I remember this. We remembered that for every 1,000 milliliters, and milliliters is abbreviated lowercase m and capital L, it gives us 1 liter of water. Good way to kind of visualize this is, I know a lot of us have these Nalgene bottles. And these Nalgene bottles on the side here have units of measure. So this one you can see that has 2 columns. One over here has ounces, like liquid ounces. And then the other one here, we have milliliters. I don't know if you can see that very well. Let me make sure you guys see it. So 1,000 milliliters right there. Okay? So 1,000 milliliters is equal to a liter of water. So whenever you guys have an Nalgene like this, with this measurement on there, you guys are actually, this 1,000 milliliters is the same thing as 1 liter of water. Okay? So let's talk a little bit more about this 1000 milliliter equals a liter by creating a second ratio table. Okay. All right. So I have created a second ratio table, which I will reveal to you in just a second. What I want you to do with this ratio table is that I want you to copy it down into your notebook. And I have a few missing values. Just to refresh your memory, I know we've done this in class, but just to get you back in this milliliters to liters, I want you to copy down this ratio table and fill in the blanks, okay? So let me show you what I got. So this one on this side shows me the value of liters. This one shows me the value of milliliters. And I have 1, 2, 3 missing values on the milliliter side. And I have 1 missing value here in the liter side. I want you to go ahead and copy down this ratio table and fill in those blanks. Ready, set, go. Are you ready? I'm going to reveal the answers to you. On my ratio table, I have placed the answers that were missing in red. So let's take a look. For this first missing value here, 2 liters is the same as 2,000 milliliters. Here, this 5,000 milliliters is actually an equivalent value of 5 liters. Okay? Here with the 6, the missing value was 6,000 milliliters. And here with this last one, we had a decimal, 8.5, and that would have given us 8,500 milliliters, okay? This one we could do a couple of tricks. I know some people like to move this decimal point and move it over 3 times to create, to multiply this by 1,000. And so that would move us over 3 spaces. So there are 2 zeros here. And so that would give us 8,500. The other way we could think about it is we just did decimals and fractions, and we know that the decimal 0.5 is equal to 1/2. And so if we want to apply this to our knowledge of liters to milliliters, we can say, well, this is half of a liter, and so therefore it'd be half of 1,000, and half of 1,000 would be an additional 500. Okay, so our total there would still be 8,000. That we got from here from the 8 liters that we converted first. And then half of a liter would be equal to half of this, which is 500. Okay? Great job. Before I let you go, I want to give you one more problem since you are organizing the water at this race. Okay? I want to take a look back at our first ratio table that we did. We said that each racer at each station would need about 20 or 250 milliliters of water, okay? So that means that for our first 4 racers, they would need 1,000 milliliters. We know that 1,000 milliliters is equal to 1 liter. So with this knowledge, here's your question. How many racers could get water at one station with 5 liters of water? I'll repeat that one more time. How many racers could get water at your first station with 5 liters of water? Using this ratio table, the information that we have here, I want you to create one more ratio table to solve for this problem. All right? Let's get to work. How did you do? Let's take a look. I'm going to walk you through this one because this one might have been a little tricky for some of you. It might have been really easy for some of you too. I'm not going to judge. Let's just get to work, okay? So let's take a look at my ratio table. So I've set it up so that one side has racers, okay? The other side, I have to think. My first ratio table, I found out the value of how much water 4 racers need with milliliters, but the question is actually asking about liters. So can we convert our milliliters here to liters? Yes, we can. Great. So on the other side then, I'm going to put liters of water. I know that for every 4 racers, I need 1 liter of water. Okay? And I'm getting that from this information right here. Okay? I've converted this 1,000 milliliters to liters. Okay? Now, the question says, how many racers could get water with 5 liters of water? Okay? So we need to figure out how many racers can get water with 5 liters of water. Okay? Now, you could go line by line and say, well, with 2 liters, we'll get 8. With 3 liters, we'll get 12. Good. But we know how to multiply, and we can use multiplication on this ratio table, right? And so that I know that I have 5 liters of water. So first thing I'm going to do is I'm going to change my line, or on the next line, I'm going to move this here. I'm going to multiply this number by 5. So now I have my 5 liters of water. With ratio tables, remember, what happens on one side also has to happen on the other side. So on this side, I multiplied by 5. So that means the same thing is going to have to happen here. I'm going to multiply this by 5. So I know that 4 times 5 is going to give me 20. Okay? So the answer to your question is that with 5 liters of water, I can have enough water for 20 racers at my first station. Cool? All right. Great job, everybody. Let's take a look at your assignments for today. So before you head on to the sunny skies of the mountains of Colorado, let's talk about your assignments for today. We're working out of our student book. There's only 1 page out of our student book that we're working on today, and that is page 154. It is labeled liquid intake. Liquid intake. Cool. So only 1 page in your student book, okay? Today also, you're doing home connections. So on home connections today, we're doing page 83 and 84. Remember that with home connections, you guys will also be doing reflections. So please make sure that after you complete your home connections, that you check your answers that your parents have, and then go ahead and email me those 3 responses to those 3 questions, okay? Today we're doing page 83 and 84. Now home connections tonight has some review on time from yesterday's lesson. So please make sure that if you need help, you'll look back on the video if you need to look back at that video from yesterday. And it also has some review on rounding, okay? So page 83 and 84, only 8 questions for home connections. Please make sure you're sending me your reflections. You guys, I miss you so much. I love taking you out to Cheeseman Park this morning or today. And so I really enjoyed our video today. Toby is taking a nap, so I'm going to quiet down and I'm going to let him nap. You guys have a great day.